So on page 374, it says geometry on the SAT. Okay, that top little box there is actually given to you during the SAT. So things you don't have to memorize, okay? So that'll be given to you. Alright. So let's go ahead and dive right into it. Page 375, number 25. In triangle ABC, which is not shown, angle ABC is 60 degrees, AC and BC are perpendicular. If AB is X, then what is the area of the triangle? Okay, so angle ABC is 60 degrees. So we have 60 degrees ABC, and it said that AC and BC are perpendicular. So AC and BC are perpendicular. And AB is equal to X. AB is equal to X. Okay. And we want to know the area of this triangle. So in order to figure out the area of the triangle, you need to know the what? You need to know the base and the height, right? And then I have to divide that by 2. So how would I approach this one?
You get the third angle.
Huh?
When you get the third angle?
Well, the third angle we know, right? What is the third angle?
30.
30. Doesn't help me about in the area. How am I going to get the area? I need to know this length, the base, and I need to know this length, correct?
It's 30, 60.
So it's a special right triangle. The 30, 60, 90 triangle. What is the ratio?
X to X.
2, 1, root 3, correct? Does this ring a bell?
Yeah.
Huh? Okay. So since this is X, we know that the base is going to be 1/2 of that, right? Because this times 2 has to be that. This times 2, right? This times 2. Okay. And then this is going to be this times root 3, right? So this times root 3, right? Because it's 1 times root 3. Right? So now I know the base and the height together. So the area of the triangle is 1/2 base times the height. Right? That seems to be the answer. Is there anything that looks like that? Looks like A is the correct answer. What is the other right triangle? Other special right triangle? 45, 45, 90. And that is what? 1, 1. Root 2, right? Because this squared plus this squared has to be this squared, correct? All right. What is this triangle called? Isosceles right triangle, right? Isosceles right triangle. Okay. Lines and angles. A circle contains 360 degrees. Thank you for letting us know that. Number 2. Number 3. A line is 180 degrees. Okay. 4. When 2 lines intersect, 4 angles are formed. And in that one, B and D would be the same, and A and C would be the same. What are those angles called?
Acute and obtuse?
No, well, they are acute and obtuse, right? A, B, C.
Oh, they're like complementary.
Complementary is what? Since you brought it up, what is complementary? No, Complementary is when they add to 90 degrees. Okay. Supplementary is when they add to
360.
180. We're throwing numbers out here. A and C are called vertical angles. They're called vertical angles, and they are always the same. So these two are also a pair of vertical angles. Okay. So as long as we're on this journey, let's go ahead and figure out the one that we always were drilled in, right? These two lines are parallel. You remember talking about this angle versus this angle, this angle versus this angle.
Yeah.
So the terms that you learned there were alternate exterior angles, interior exterior angles. You also learned about corresponding angles. Okay? So you might want to kind of briefly review that. Okay? Alternate interior, alternate exterior, alternate interior, alternate exterior, corresponding, corresponding. Okay? All right, so that's that. They don't have that. Oh, that's funny. You would think they would have that. 6. Two lines are perpendicular to each other. Oh, yeah, whatever. Okay, 49 degrees. Okay. And oh, number 7. There they are, right there. So number 7. Flip the page. Page of 380. It's right there. There's the. They don't actually label them as what kind of angles they are, but they go ahead and say that all the small angles are the same and all the large angles are the same. And when you add the small angle, the large angle together, they're 180 degrees. Okay, number 12. In figure above, L2 and L3 are perpendicular. Not perpendicular, they're parallel. Which of the following could be false? Okay. A and E are the same. Is that correct?
Yes.
That is correct. They're alternate interior angles, so they're all the same. B plus E would be 180 degrees. That is correct. L1 and L4 are perpendicular. There's nothing to support that, right? C is equal to D. Are they always equal to each other? Because they are vertical angles. Okay. Converting degrees to radians. What is the relationship there? 360 is 2?
Wait, what is it?
You're close.
Oh, 360 is pi.
360, no.
What?
360 in US degree is
It's
2 pi radian.
I was on it.
Okay, which means that 180 degrees is pi rads or radian or whatever, okay? So 180 degrees is pi radians, okay? Triangles. Let's move on to triangles. Every triangle contains 180 degrees. What kind of triangles are there? What kind of triangles do you know? Huh? You know right triangles, right? There's a right triangle. What else?
Isosceles.
Okay. Isosceles triangle.
Oh, equilateral. It's like
Equilateral. Okay, good. What? Scalene. What is scalene?
When they're all different.
And all the interior angles are acute. Okay? Then it's a scalene. What if one of them were obtuse? It's an obtuse triangle, right? you get all of them? Yeah, you got all of them. Okay. All right, that's good. Isosceles triangle, equilateral, right. Perimeter of a triangle is just adding all the sides together. Area is 1/2 base times height, that's good. Let's go to page 386. Number 3, the regular hexagon shown above is divided into six congruent equilateral triangles. What is the measure in degrees of one of the interior angles of the hexagon?
60.
Why?
Because 60 times 3 is 180, and that's half the circle.
Hmm?
That's max.
The reason why it's 60 is because 180 divided by 3 is 60, right? Because it's equilateral, right? Which means that all 3 angles are the same. So you were good up till then,
Wait,
and then you added something else.
Well, I was picturing it as a circle.
Okay, if a circle as a circle, so what does that have to do with anything?
Well,
Because what we did was you drew a
it's
circle
just
around it.
easier than dividing 360.
By 6.
Yeah.
Which is what they did in the origin, right? In the center, right? You can
Right,
think about it
but
that
I
way.
just made it easier and cut it in half.
All right. SOHCAHTOA.
Holding the bread.
SOHCAHTOA. This is the trig portion. Trig. I don't think trig ever shows up. Trig is not. Are you supposed to know trig? Not on the SAT, right? Are you supposed to know trig on the SAT?
It says tested
Infrequently. Where is it? Similar triangle. Well, SOHCAHTOA then. Okay. 11. In the triangle above, sine x is equal to 0.8. Cosine x is 0.6. What is the area of the triangle? Okay. So you have 10. And you have x, and you're given that sine x is equal to 0.8, was it? Cosine x is equal to 0.6. So that means this here is what? Or let's do sine x first. Sine x is this guy over this guy, right? So this guy over this guy is 0.8. So this guy is going to be 0.8 times 10, so it's going to be 8. By the same token, this guy here is going to be 6. So the area is going to be what? 6 times 8 divided by 2, which is 24. Pythagorean theorem.
what is it?
Pythagorean theorem is x squared plus y squared is equal to, or a squared plus b squared is equal to c squared, correct? All right. Let's go to page 389, number 15. In the angle, or the triangle ABC, AC and BC, blah, 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 cosine is blah, blah, blah. What is the value of tan ABC? ABC, where AC and BC are parallel, AC and they're perpendicular. And the cosine of, let's redraw this. A, B, C. Cosine of this angle is 12 over 13, which means that this guy here is 12, this guy here is 13. Right? That way it's 12 over 13. Right? So what is this guy here then? How would I find this guy here?
You do
Okay, so x, I don't know what it is. Correct? Right? So 5, 12, and 13, right? And do you want to know what is the tangent of this angle? So tangent of this angle would be what? So toa,
55.
opposite over adjacent, right? So 5 over 12. Okay. Okay. So these are called what? Does anyone know what these are called? There's a special name for three integers that satisfy the Pythagorean theorem.
The SSA side that thing?
No. They're called Pythagorean triplets, right? Because there are three of them.
That one.
5, 12, and 13. Is anyone else, anything else that you know? Three, 4, and 5?
Oh yeah, that's a good one.
3, 4, and 5, right? 3, 4, 5, right? So 3, 4, 5, and 5, 12, and 13 are probably the most, I mean, those come up the most. Then there's 18, 15, no, 8, 15, and 17 or something like that. I don't know, whatever. But anyway, so those are kind of nice to know. Right? So 3, 4, and 5, and 5, 12, and 13. So when you actually read this question, it says 12 over 13. You already should be kind of chugging in your mind that, oh, 5, 12, and 13, that one. Okay. Flip the page, go to page 390. They talk about the special triangles. Special triangles are the 30, 60, 90, 45, 45, 90. Right? The 2, 1, and square root of 3. 1, 1, and square root of 2. That one. Now, similar triangles, we talked about that. Let's go to page 392. So number 16. In the figure above, a triangle ABC, a similar triangle XYZ. What is the value of cosine A? Okay, so how would you figure this out?
Don't you first gotta find yx or xy?
Can anybody tell me what the maximum value of cosine is?
Get it? No. What's that thing?
What is cosine? Has anybody seen the cosine graph before?
Yeah.
Yeah. So it looks like that. It looks like a.
What has like the curve on the
It's called the sinusoid, right? Because it looks like. It looks like this, right?
Yeah.
Right. Anybody know what this value here is?
1 x.
1. What is this value here?
-1.
-1. So cosine has to always be between -1 and 1. Look at the answers. Which ones fall into that? It's not C or D, right? So you can immediately eliminate those two, right? Okay, so here you go. Cosine A is the same as cosine X. Can you agree to that? Because they are similar triangles, right? So cosine A is the same as cosine X, where X is this guy, find out what x is, right? To find the cosine value of this guy. The cosine value of this guy is this divided by this, correct? But I don't know what this is. So, 4 squared, x squared, 2 squared. Does this look so familiar? 1, 2, root 3, 2, 4, 2 root 3, right? Which means that this is a special triangle, right? But the cosine value of x is going to be equal to okay, so that's that. Circles, a circumference of blah, blah, blah. Okay, circumference of a circle is pi d or 2 pi r. The area is what? Of a circle is?
Pi squared.
Pi r squared. Are circles, are they in? Oh, they're tested infrequently. Circle defined by the equation, blah, blah. So we're doing number 22 here. Has its center at 4, 4, and includes 0.78 on the circle. This is shown in figure above. What is the area of the circle shown? So in order to know the area, what do I need to know?
The radius.
The radius, right? So this is the same as that. So what is the radius in this circle?
For number 2.
Number 22 on page 395.
We can find the slope.
It's just 5, right?
Is it 5?
It's just 5, right? Because this is r squared, right? This is r squared. In your equation, if you go back to page, does it give you the equation?
Well, it's just equals 25.
Yeah, 25 is 5 squared, so no, I'm just, yeah. So this is 5, so the radius is 5. So the radius is 5, here is equal to pi r squared. 25 pi. Arcs and sectors, arc and angle, then radians, that's not going to be on the test. And highly, okay, so we're going to skip that. Rectangles and squares. What is a square and what is a rectangle?
A square has sides.
Square is a rectangle with equal sides. Right? What other kind of quadrilaterals are there?
Rhombus.
The rhombus. The rhombus. What else?
Parallelogram.
Parallelogram, right? The parallelogram.
The trapezoid.
What makes the parallelogram
It has
particular?
2 sets of
what?
2 sets of parallel sides.
Okay.
And there
Okay.
are 2 sets of what do you call it?
The two diagonals of a parallelogram,
Oh yeah.
they bisect each other. Okay. That's a parallelogram. Okay. Is a rectangle a parallelogram?
Yes.
Right, because both of them are yeah, both sides are parallel, correct? Okay, so a rectangle is a parallelogram. Okay. What about a rhombus? Is a rhombus a parallelogram?
Yes.
Right, because they're both parallel. They're actually parallel and equal, right? Basically, you took a square and you kind of just squished it in, right? So if I had a square and I squish it in like this, I'm going to end up with, no, it's a rhombus. Okay. A rhombus, it would look like that, right? So they would actually, so yeah, these sides would be the same. They are parallel. So they are a parallelogram. Okay. Okay, parallelogram, blah, blah, blah. Volume, I'm not going to worry about it because they're going to give you all the equations. Okay, we're good with geometry. Okay, let's take one more break. Give you another 5-minute break.